Imagine, if you will, a long, shimmering metallic bead chain. It's carefully coiled, nestled comfortably inside the confines of a pristine glass beaker, a common sight in any laboratory setup. This seemingly simple arrangement holds a secret, a surprising defiance of what we think we know about gravity. Within that coil lies a reservoir of potential energy, waiting to be unleashed. Each tiny bead, linked to the next, contributes to the overall stored energy, a physics lesson waiting to happen. It's a system yearning for release, a delicate balance about to be disrupted. Now, picture a hand gently reaching in, grasping one end of the chain and carefully dropping it over the side of the beaker's rim. Our intuition tells us that gravity should simply take over, pulling the chain downwards in a predictable, straightforward manner, right? But instead of a simple descent, something truly astonishing, something quite unexpected begins to unfold before our very eyes. The ordinary becomes extraordinary in a dramatic display of physics. As the chain begins its fall, defying our initial expectations, it doesn't just drop, it leaps upward with surprising energy. It's as if an invisible force is propelling it skyward, a clear violation of our everyday understanding of gravity. The chain, now airborne, forms a graceful, elegant arc above the beaker's rim, a curve that seems to dance in defiance of the forces acting upon it. It's a beautiful, almost artistic display of physics, in action. For a fleeting moment, it looks as if the chain is completely defying gravity, almost suspended in mid-air. It appears to be floating, a stream of metallic beads magically held aloft. Only then, after its brief moment of apparent levitation, does it succumb to the inevitable pull, cascading downwards in a continuous flowing stream towards the floor. This captivating display isn't a magician's trick, nor is it a cleverly crafted illusion designed to deceive the eye. Instead, it's a genuine scientific phenomenon, a real-world demonstration of physics that you can recreate and explore in the comfort of your own home. The continuous motion of the chain creates a mesmerizing loop, a captivating visual that draws you in. It's a self-siphoning stream, a continuous flow of solid matter seemingly defying the conventional laws of physics. For those encountering this spectacle for the very first time, it's often a moment filled with a mixture of disbelief, wonder, and an insatiable curiosity to understand what's happening. The immediate question that springs to mind is, how can a chain, seemingly governed solely by the downward pull of gravity, initially travel upwards against that very force? This seemingly simple demonstration presents a complex puzzle, one that has intrigued and fascinated scientists and researchers for years. The captivating nature of the chain fountain has also captured the attention of YouTubers and science content creators, leading to countless videos and explanations attempting to unravel its mysteries. This phenomenon is widely known as the chain fountain effect, sometimes referred to as the Mould effect, named after the scientist who first brought significant attention to it. The chain fountain serves as a powerful reminder that even the most fundamental forces like gravity can interact in unexpected and surprisingly complex ways, challenging our understanding of basic scientific principles. The mesmerizing dance of the chain fountain invites us to take a closer look, to observe the intricate details of its motion and consider the forces at play. Ultimately, the chain fountain encourages us to appreciate the hidden wonders that exist all around us, transforming everyday objects into sources of scientific discovery and awe. So, what exactly is this mesmerizing phenomenon we call the chain fountain? It seems to defy gravity, almost like a magic trick right before your eyes. But it's not magic, it's physics. It's that captivating moment when a bead chain, coaxed by gravity's gentle pull from a container, begins its dance. Instead of simply cascading down, it rises in a graceful arc, seemingly defying the very force that draws it downward, before finally succumbing to gravity and falling. It's a beautiful blend of upward and downward motion. Now here's a key point. Not just any chain will do to create this spectacle. The effect is most dramatic, most visually stunning, with long, flexible bead chains. The longer and more flexible, the higher the fountain seems to soar. Think of the kind you often find on dog tags, those little ball chains on light poles, or even some keychains. These are perfect examples. The setup itself is remarkably simple. All you need is a container, like a beaker or even a bucket, and a long bead chain piled loosely inside, ready to be unleashed. To get things started, give the chain a gentle nudge, and gravity immediately takes over, pulling it down, and in doing so, tugging the rest of the chain along for the ride. But here's where the magic truly happens. Instead of just meekly dragging over the rim of the container, the chain somehow gathers itself, and pushes itself upward, gaining altitude against the downward pull. It's this upward thrust that creates that signature fountain shape, a curve that seems to defy logic. Now, for comparison, try this same experiment with a rope instead of a chain. You'll quickly see that it just slumps unceremoniously over the edge. No fountain, no spectacle, just a simple fall. The bead chain's unique structure is key to this behavior. Its mass, the amount of material it contains, its flexibility, how easily it can bend and curve, and the fact that it's made of separable links, each able to move independently. All of these factors combine to make the magic possible, to create this seemingly impossible fountain. It's a striking example of how different materials, even when subjected to the same fundamental forces, can behave in dramatically different ways. The chain's clever design, its interconnected yet flexible nature, turns what should be a simple fall into a spectacular display of physics, a captivating demonstration of the principles at play in our world. The chain fountain often feels wrong, almost unsettling to our brains, because it challenges our intuitive understanding of how gravity should work. And it's precisely this feeling of wrongness that sparks our curiosity, igniting a desire to understand the underlying science. That's why it's become such a classic physics demonstration, a staple in classrooms and science museums around the world. It's beloved by anyone with a curious mind, by anyone who enjoys the thrill of unraveling the mysteries of the universe, one chain link at a time. When the chain fountain went viral, people rushed to explain it. Many thought inertia was the answer. Maybe the links overshot the rim due to momentum. But that doesn't explain the sustained high arc, or why a higher drop creates a taller fountain. Others guessed air pressure was involved, but the effect works in a vacuum, so it's not about air. The real mystery was in the chain itself. Gravity and inertia alone couldn't account for the phenomenon. Scientists realized another force was at play, one that came from the interaction between the moving chain and the pile inside the beaker. The answer wasn't in the air, or just in motion. It was at the bottom of the beaker, where each link begins its journey upward. The chain fountain's secret lay in the mechanics of the links themselves. Solving it meant looking closer at how the chain interacts with itself. The accepted explanation, while partially correct, often overlooks a critical component of this fascinating phenomenon. We're about to delve deeper, beyond the surface-level understanding, to truly unravel the mechanics behind the chain fountain. Prepare to have your understanding challenged as we explore the intricate interplay of forces at play. Is a dance of momentum, a continuous transfer of energy from one link to the next. Each link influences its neighbor, creating a wave of motion that propagates through the entire chain. This momentum is what keeps the chain flowing, defying gravity in a seemingly impossible way. Tension, the invisible force that binds the chain together, is also a key player. It's the internal stress within the chain that allows it to transmit forces efficiently. Without tension, the chain would simply collapse, unable to maintain its structural integrity, and a crucial kick from the pile. This upward force, often underestimated, is the secret ingredient that elevates the chain fountain beyond a simple gravitational fall. It's the reaction force that propels the chain skyward, creating the mesmerizing arc we observe. As the chain falls, gravity creates tension, stretching the links and preparing them for the upward launch. The gravitational pull is the initial driving force, setting the stage for the subsequent chain reaction, pulling more links up and out, sustaining the fountain's continuous flow. The upward motion is a direct consequence of the interplay between gravity, tension, and the crucial kick we mentioned earlier. But when a link is lifted from the pile, the magic truly begins. It's at this point that the hidden mechanism reveals itself, transforming a simple chain into a gravity-defying spectacle. It pivots quickly, a subtle but significant movement that redirects the forces at play. This pivot is the key to understanding the upward kick. One end lifts, the other pushes down on the pile. This creates a seesaw effect, where the downward force on one end generates an equal and opposite upward force on the other. Newton's third law kicks in. For every action, there is an equal and opposite reaction. This fundamental principle of physics is at the heart of the chain fountain's behavior. As the link pushes down, compressing the links beneath it, it's not just a passive force, it's an active engagement with the pile. The pile pushes back up, with an equal and opposite force, launching the link skyward. This is the kick we've been referring to, the crucial element that defies gravity, giving the link an extra boost, accelerating it upwards against the pull of gravity. This boost is what allows the chain to rise higher than it would if it were simply falling. This upward kick, powered by Newton's third law, is what launches the chain into the air, creating the illusion of a self-propelled fountain. Each link gets this push, one after another, in a continuous and synchronized manner. And together, they create the fountain's arc, a graceful curve that defies our intuitive understanding of gravity. The faster the chain falls, the stronger the kick, because the impact force is directly proportional to the velocity. So a higher drop means a taller fountain, as the increased velocity translates into a more powerful upward thrust. It's a self-reinforcing loop, a dynamic system where each action amplifies the next, of energy and momentum constantly being transferred and transformed within the chain. Imagine pulling a folded ruler straight, a simple analogy to visualize the forces at play. The end whips around and bounces off a surface, demonstrating the transfer of energy and the resulting rebound. That's what happens with each chain link, a miniature version of the ruler experiment repeated countless times. It bounces off the pile, getting kicked upward, contributing to the overall fountain effect. This mechanical kick is the missing piece, the crucial element that completes the puzzle, turning a simple fall into a spectacular fountain, a testament to the power of physics. It's a beautiful example of complex behavior, arising from the interaction of simple components, from a simple system, showcasing the elegance and power of physics in action. The chain fountain is physics in motion, a dynamic demonstration of fundamental principles. Right before your eyes, a captivating display of science in action. There's another layer, phantom momentum. When a stationary link joins the moving chain, it must accelerate instantly, requiring extra force. This force is more than just lifting, it's about imparting momentum. The chain's tension must overcome gravity and accelerate new links. This creates an internal resistance demanding a strong upward pull. Combined with the kick from the pile, this momentum transfer helps launch the chain. The bead chain's discrete links maximize this effect, unlike a rope. Each link's acceleration adds energy to the fountain's arc. The chain fountain is an experiment you can try at home. Changing the chain's weight affects the fountain. Heavier chains make higher arcs. The container's shape matters too. A wider beaker changes how the links interact. Some use funnels or angled blocks to guide the chain and alter the fountain's shape. Drop height is key. A longer fall means a higher, more dramatic fountain. Large-scale experiments like dropping chains from balconies confirm this relationship. When the pile runs out, the fountain vanishes. The last links just drag over the rim. This proves the pile's kick is essential. The chain fountain is a simple, elegant physics puzzle anyone can explore. It turns your kitchen table into a science lab. The chain fountain is more than a physics trick. It's a window into the beauty of nature's laws. It combines gravity, tension, and momentum in a way that surprises and delights. The best part? Anyone can try it, no lab required. It shows that science is for everyone, not just experts. The journey from confusion to understanding mirrors the scientific process itself. The chain fountain connects fundamental physics concepts in one elegant demonstration. It brings abstract principles to life, making them tangible and exciting. So next time you see something puzzling, embrace the mystery. Stay curious, keep asking questions, and marvel at the wonders hidden in the everyday world. The chain fountain reminds us, never lose your sense of wonder.